I just wanted to start off by saying that I certainly hope everybody has remained safe and well. I definitely miss getting to see you all in person for these meetings, and I'm very much looking forward to when we can all get back together. So today I'm going to be going over some work from my dissertation looking at shifts in spatial patterns of habitat use and mortality of winter flounder in Rhode Island waters. So I'll start with some acknowledgements. For this work, we got data from the Rhode Island Department of Environmental Management, as well as Normando Associates. Our funding came from Rhode Island Sea Grant, and we received additional logistics support and contributions from the Rhode Island Marine Fisheries Institute and the Rhode Island Division of Marine Fisheries. So I think many in this audience will be familiar with southern New England winter flounder. This was once a very abundant and productive fishery. As you can see in blue, however, in this figure, the population really crashed throughout the 1980s. And so this was at least partially due to a period of very high fishing mortality here in red, extending through the early 1990s. However, as the stock reached very low abundances, harvest was restricted starting in the mid-90s or so, except the stock never recovered. As fishing mortality was lowered and lowered and lowered, we never saw the expected population increase. The answer to why that may have occurred may be here in recruitment, where during that period of elevated fishing mortality, we had relatively high and stable recruitment through 1995 or so. However, as fishing mortality was lowered to try to promote population recovery, recruitment entered a downward trend that is not yet reversed. And as a result, the population has never fully recovered despite severe limitation of commercial harvest. So this has led to a lot of hypotheses that perhaps increased mortality during this early life cycle, limiting recruitment, is causing the population to not be able to recover. And this is certainly plausible. There have been plenty of studies in the region showing that predation or high temperatures contribute to high juvenile mortality. Zooming in on Narragansett Bay, although this is something of a subpopulation in the region, we've seen very much the same trend as the southern New England mid-Atlantic bite stock broadly, where beginning in the 1980s, our Narragansett Bay population really entered a steep decline from which it has never recovered. Now, this population specifically, in an earlier part of my dissertation, showed that this decline is due, at least in large part, to an increasing trend in mortality during the first summer of life. And this increasing mortality is related to high summer temperatures, summer hypoxia, and predation by striped sea robins and double-crested cormorants. So, for this work, we wanted to look at how spatial distribution has changed. As this population has contracted, are we seeing them use habitats differently, and does this differ throughout the life cycle? Specifically, we wanted to ask the following questions. Have spatial distribution shifted over time for any part of the life cycle? How does temperature influence the observed spatial abundance patterns? Is there coherence in habitat use among adjacent life stages? So, for example, does the spatial abundance pattern of a given cohort last fall have predictive power of what we would observe for a spatial abundance pattern of that cohort this spring? And finally, do we appear to see any spatial patterning in mortality for those early life stages that appear vulnerable? So to dig into this, in Rhode Island waters, we're very lucky to have very long and detailed data on many life stages of winter flounder. For this work, I'm starting at the young of the year stage, or YOY, where we have data from the Division of Marine Fisheries, same survey going back to 1988. And then for the older life stages pictured here, we have data going back to 1979 from the Division of Marine Fisheries trawl survey. Although they don't collect age information for all of these fish, we are able to assign fish to age classes probabilistically based upon their total length and season using a log normal mixture model. So once we have our fish assigned to their year classes, we split our data up into 10 polygons representing Rhode Island state waters, as pictured here on the right. So we're representing our spatial domain in polygons here because our stations tend to be several kilometers apart, as many of you will be aware, in an estuarine environment, we expect very dynamic gradients of habitat suitability. I think for those who've done field work in estuaries, we know that even if you do a second tow one boat width over from a given tow of a net, you may get a totally different result. And so we don't want to fit a continuous space model here where we'll be interpolating over what is likely to be very highly variable information. So instead, we split our state waters into polygons, and we're looking at kind of average abundances across these different regions. Really, we're interested in Narragansett Bay here. So we have 9 polygons representing Narragansett Bay, 3 for kind of the headwaters of the estuary, 3 for the mid-bay, and 3 for the lower bay, and then a 10th polygon representing just kind of the rest of Rhode Island state waters in the coastal zone and around Block Island. In defining these polygons, we wanted to make sure we had at least one station in each polygon. So in blue over here are the Division of Marine Fisheries seine stations. In red are the fixed trawl stations from the seasonal trawl survey conducted by the Division of Marine Fisheries. The seasonal trawl survey also has a bunch of random stations, but we wanted to make sure these polygons had at least one seine station and at least one of the fixed trawl stations that's sampled every year. And then for all of the information available in a polygon in a given year, we averaged the annual catch together and rounded up the result to the nearest count. We round up in this case because we want to discern between cases where we say caught 1 winter flounder in a given age class in 3 tows versus catching 0 winter flounder in 3 tows. We want that positive result to be distinguished in the model. And then we modeled this with what's called a spatiotemporal conditional autoregressive model for each life stage individually. Now, while that's an obnoxiously long name, it's essentially a generalized linear model. This is count data, so we're using Poisson distributed errors. And this model has a spatiotemporal random effect, where the random effects are correlated among adjacent polygons, meaning we have spatial correlation among polygons that are sharing an edge. And the random effects are correlated through time among adjacent years, where last year's abundance information informs this year's as a first-order autoregressive process. So with that model fit, we can then look at how we see what temporal trends we see rather in the spatial patterns of habitat use over time, and use the model outputs to estimate spatially explicit mortality rates for those early life stages. And so I'm going to just pull out a few of the highlights here. Here are the results kind of binned into decadal-ish time intervals for the October young of the year life stage. So what I want to point out is in the late 80s and 90s, there was really high abundance throughout almost all of the Narragansett Bay estuary, except for this lower east passage here, which is a very deep area. That held up through the late 90s into the early aughts, and then we see a very large drop in abundance in the late aughts to 2010s. What I really want to point out is this disproportionate drop in abundance on the eastern side of the estuary. While we've seen a decline in abundance everywhere, there's a very severe decrease over in the Sakonnet River, Mount Hope Bay area. And so while this is just one life stage, we see a similar pattern in other life stages. We're seeing a contraction in the spatial habitat use as this population has declined. There's still some flounder over here, but they're becoming relatively more concentrated over time in the estuary. Another pattern I wanted to point out is for the spawning ages. So this is in fall. Because we have trawl data in the Rhode Island coastal waters now, you'll see that final polygon appearing. And back in the 70s and 80s, we see really high abundance of these spawning fish throughout all of Rhode Island state waters. And as we progress through time, that largely holds up. Some decline on, again, this eastern side of the estuary. What I really want to point out is abundance has increased in Rhode Island's coastal waters in this extra polygon over time. And that is also true. We're now looking at the same spawning-sized fish in the spring, where we see very strong abundance kind of holding up through this coastal zone. Now, while this coastal area may have winter flounder that are not just spawning in Narragansett Bay, they may be spawning in Rhode Island coastal ponds, or we might have some coastal spawners. We know from all available data that essentially nowhere in this area are winter flounder increasing in abundance. So instead, we're interpreting this kind of accumulation of biomass in the deeper coastal waters as perhaps a change in migration phenology. Winter flounder flounder are winter spawners. The adults make inshore-offshore migrations where they enter the coastal zone and estuaries in winter to spawn and then head back offshore in the late spring. And so we're thinking that this may be a signal that the migration timing has shifted. Separate analysis I did recently showed that for a number of species, not including winter flounder, in Rhode Island waters, we've seen very large changes in the past 2 decades in migration timing. That may be going on here, where our fish are entering the estuary later in the fall, after our fall surveys going on, and then they're leaving the estuary earlier in the spring before that DMF seasonal trawl survey is occurring. And that results in essentially it looking like there are now more fish in coastal waters. Other fun things from the model, we saw that there was weaker spatial correlation among areas of the bay for the earlier life stages than the later life stages. Perhaps this makes sense. These small winter flounder aren't going to be moving around too much, so you might expect different broad areas of the bay to be acting in somewhat independently, whereas the older life stages for flounder that can move around, perhaps it makes sense we'd see stronger correlation among bay regions. For temperature, across age 1 and up fish, we saw a positive relationship between temperature and abundance in spring, and a negative relationship with temperature and abundance in fall. Now, this makes sense for those fish making those inshore-offshore migrations. They're leaving the estuary in summer to get away from warm temperatures. But this also appeared for age 1 fish that are not yet making those spawning migrations. So this suggests that even within the estuary, these fish are moving away from hot summer fall temperatures and perhaps into deeper waters. And that's relevant because we also saw that spring life stages were correlated to the abundance pattern we observed from the previous fall, but the fall was not correlated to the previous spring. So this means that basically what we observed last fall, where those flounder were last fall, kind of holds through the winter and has some predictive power for the following spring, but the spring does not have predictive power for the following fall. So again, if there's a negative relationship between abundance in various areas and temperature, it would make sense then that these correlation patterns are essentially getting kind of jumbled during the summer months when temperatures get high. And like I just said, that's true for the non-migratory and migratory life stages. And lastly, to look at spatial patterning and mortality. Here is the same October Young of the Year panel I showed earlier. Now over it is the July Young of the Year spatial pattern. For July, we just kind of see roughly the same story across all 3 time bins, where they're just in low abundance in kind of these lower reaches of the estuary in the southwest corner. So recall that my earlier work showed that increased mortality between July and October of this first year was related to high temperatures, hypoxia, and predations by striped sea robin and cormorants. So if we use that model output, the difference in abundance in each polygon between July Young of the Year and October Young of the Year, we can estimate a rough mortality rate, which I've done here. I normalize the mortality rate so that its value of 0 is the time series mean mortality. Red here is high mortality, green is low mortality. Now, a note of caution, there's a lot of uncertainty in the model fit, so we don't want to make overly confident conclusions here. But there is evidence that these upper reaches of the estuary are displaying higher mortality rates over time, and in recent years, particularly this eastern side of the estuary where we've seen a large drop in abundance. Now, despite the uncertainty, this would make sense if we expect high temperature and hypoxia to be related to mortality. Those are things that are occurring in these upper shallow reaches of Narragansett Bay. So to wrap this up, we see that as the winter flounder population has declined, their habitat use has contracted over time, and that for the spawning adults, we have some preliminary evidence that the migration phenology may have also shifted, though more research would be needed to confirm that. We see that abundance has been positively associated with temperature in spring and negatively in the fall. This is a species that does not like very high summer temperatures, so this is perhaps expected. And relatedly, we see coherence in spatial abundance patterns between the fall and spring life stages, but not between going from spring to fall, which is likely, again, due to those relationships with temperature. And finally, though we need kind of more research to confirm it due to the uncertainty involved, there's at least preliminary evidence that there's higher rates of juvenile mortality in those upper bay areas that have been the historic kind of stronghold nurseries for winter flounder. And that is all I have, so I'll be happy to take any questions.
Great.